Well, hello everyone, and welcome to this Art of Writing Dockerfiles session. Uh, Today's session also serves to be. And welcome. Okay, I'm just gonna mute files session. All right, I'm live on multiple platforms, so they're just putting everything on mute. And welcome everyone on the Zoom channel. Welcome everyone on the YouTube channel. I see a lot of bunch of people on YouTube and also the LinkedIn Live. And we are also live on the Facebook group, which I'm not monitoring for now. But this session serves to be a sort of a session where I'm going to talk about and teach you about how to write Docker files, how to build container images. And this is one of the missions for our 50 days Kubernetes challenge as well. So I'm going to begin explaining to you what is this 50 days Kubernetes challenge, because some of you who are new and who are not aware of it can understand what the challenge is all about. And anyone who has signed up, so we have hundreds of people who have signed up for the 50 days Kubernetes challenge now. And this is basically 9 missions which would help you step by step master the world of Kubernetes. And this is basically designed in a way that this follows a mission based approach where every week, almost every week, there'll be some gaps during like last week of December and so on. So, but this is going to go for about 7 weeks. So that's what comes to 49 days. So one day added. So 50 days challenge. That's how it is designed. Take one day for orientation. And what are the missions that we are going to complete? You and I together. First is the mastering the art of Dockerfile. That is what we are going to talk about today. That is the first step. It's about Docker, yes, but when you want to get started with Kubernetes, you have to have an image created. That is the first step towards the containerizing your application and then deploying it with Kubernetes. That is the reason why we start with mastering the art of Dockerfiles. We also understand Docker networking and how to deploy microservices with Docker Compose. That's what we take up next week. Then we learn to deploy pods in Kubernetes. That is the time when we also set up a Kubernetes environment using a tool called as Kind. And everything about pod, like how do you design a pod, how do you write the pod spec, how do you troubleshoot pod issues, the common pod issues. I'm going to do the teaching sessions every week as well, where I'll explain how all of these concepts to you and have you do some mini projects, like nano projects, as I call it, right? So small, tiny projects to help you understand and, also implement these topics as well. The mission number 4 is about making the applications high available and scalable. That is where you will learn about what are replication controllers. And along with that, same week, I'll also be teaching you about namespaces and how do they work, which serves the the foundation for the multi-tenancy. The mission number 5 is going to be how do you interconnect the applications using Kubernetes services. Services being one of the most important topics in Kubernetes world, and we are going to do a deep dive into the service networking. So how do you expose your application to the outside world? How does one microservice connect to another in Kubernetes using the same service networking? How does that happen with the DNS based service discovery? So we will dive deeper into that. Along with that, we will also talk about the CNI part, the container, the container network interface, the the standard that Kubernetes uses to do the underlying networking. Mission number 6 is going to be how do you deploy application with zero downtime. That's the default rolling update Kubernetes deployment strategy. So how do you construct that deployment, and how do you look at the strategy? How do you understand the configuration for that, and what is possible with Kubernetes, what is not? I'll brief you on that as well. And then we'll talk about the data persistence, and that's where we talk about all the storage objects. That includes persistent volume claim, storage classes, provisioners, and how does it really come together, basically. Mission number 8 is going to be about setting up edge routing with ingress controllers. That's how you typically expose your application and microservices. It acts like a router. And, you can take an example of Nginx, HA proxy, traffic, Ambassador. There are many edge routers or ingress controllers. Even your cloud application load balancers like ALBs are the examples of ingress controllers that can integrate with Kubernetes as well. And finally, we'll end it up with how do you package your application and get ready for deploying in different environments. The same package applies in different environments with different configurations, different profiles, and that is possible with the tool called as HEM. And that sets up the foundation of Kubernetes for everyone. Anyone who is trying to master Kubernetes, all these missions would help you get to the next level for sure from where you stand right now. And that is about this, that is this 50-day Kubernetes challenge is all about. Again, it's not going to make you sort of a master immediately, but it will set up the right foundation on top of which you can start your own journey towards Kubernetes mastery and also go and strive for the certifications from there on. So what is the duration of this challenge? So it's going to be 50 days, 7 weeks. We start on November 23rd today. We're kicking off today, and I'll be sharing the challenges every week, starting today, later today or tomorrow rather. And you would have a week to complete the challenge. The weekly challenges will be shared with you. And then we are going to have the interactive sessions as well. So that's how we get started. So any of you haven't started with this challenge, you can sign up by going to devopsclub.co/Kubernetes. It's devopsclub.co/Kubernetes. Now, I'll also talk about what is open to all who participate in the challenge. And we also have the DevOps School of Devops community members, the paid members. So what is open to all is the weekly email challenges. Plus, I have started creating a course page like this, the 50 days Kubernetes challenge, and I'm adding everything, the details of the challenge, what is the prerequisite knowledge that you must have, and I'll point you to the topics also, and either you could take those up on your own, or you can subscribe to the membership and go through our courses as well to learn those topics of the week. I'll be teaching you certain things, but if you want to dive deeper into it and understand it and do the labs, you can basically take the courses as well. There'll be weekly challenges. You will receive emails from me, as well as you'll have access to that course where you'll see everything, including the recordings as well. And there'll be weekly live coaching sessions like what we are planning for today. You'll get an idea about what happens during the live sessions and how much value can it add, because this is similar thing that I do for my corporate clients as well. The corporate trainings is just a gist of that. It's more elaborate in the corporate training, more structured kind of workshops, but you're gonna definitely benefit out of this. I'm pretty sure about that. And paid members get access to the courses, the labs, the community on Discord, where you can ask questions, you can connect with other community members. I'm trying to create some sort of a sort of a pairing system or accountability system where you help each other and make sure that you complete that in time, and someone is there to push you and so on. So that's something I'm creating. Besides that, we have already started a community on Discord. Everyone will have access to recordings, so it goes here really, and you'll be in Zoom call to ask questions live, because I would not have bandwidth to take questions from all the live streams. About the questions, I would take questions from the Zoom call live while I'm talking about. So if anyone of our members, silver and gold members, have questions, you can ask me during during the live sessions. All the other questions I would take towards the end of the session based on the time, or just ask questions and post it there, because all these are live stream recorded. So I would be answering questions through my YouTube channel as well. So I'll create another video where I'll answer specifically all the questions that are asked in the session, if they are not being answered already, either through the shorts or through let's say the actual longer format videos. And you can sign up to or subscribe to the School of Devops channel on YouTube as well. If you just search for School of Devops, you'll find me. A lot of you are already on the YouTube stream, so you can have it subscribed so that you get an update with the answers to your questions as well. Now to our first mission, that is about the art of writing Dockerfiles. And let's just focus on that one mission for this week. And what we're going to do is I'm going to teach you the art of writing Dockerfiles, building images, container images, etc. And then I'll give you some challenges. So challenges as in certain projects to complete, certain things to learn, certain topics that you would have to learn this week, etc. And that is how we are going to proceed from here. Now, talking about this challenge, let me fold everything else so that we just focus on, or let me just focus on this part. All right. I think I messed something up. Never mind. What do you need in order to master the art of writing Docker files, and what do you want to get started with before you approach this and start practicing and doing things that I teach you today? The first thing that you would need is a Docker environment. And since you are part of the challenge, if you haven't signed up, just sign up using the devopsclub.co/Kubernetes. And I've given the detailed description of the topics that you should know and should get started with before you approach building container images, because you need a Docker environment. And I've given the links to install Docker environment, etc. You also should get started with the container technology and the underlying technologies like C groups, namespaces, copy and write, overlay file systems, and all those conceptual understanding of that. If you haven't gone through those topics or don't know about it, I have opened up the course, the first topic, first chapter, which is conceptual understanding of containers, to everyone. And then you learn to run and operate containers. And that is where you learn how to launch containers. What are the common options, the -IDT, 3 types of port mappings, how do you troubleshoot containers with exec logs, how all of that works. So you can go through that through the course or otherwise. And you should learn about the actual writing Docker files and building images. That is what we are going to focus as part of today's session, right? So let's get started with that topic. And to understand how to build container images, I'm going to show you and take an example application. It's a Java Spring Boot based application. And, I will demonstrate 2 different ways of building images. One is using a manual approach. And that's what you typically would start with to understand the process of building a container image, right? And the second approach is where you would actually write a Docker file and do it using that. So first approach is more like a manual approach, step-by-step approach. I'll explain the steps. And second approach is where you convert it into the Docker file. Let me share my screen and demonstrate all of this to you. Okay, I realized I didn't share my screen earlier. So let me take you through those missions again. So these are the missions. These are the 9 missions. You might be able to see my screen right now. And these are the 9 missions that I just described. This is the first mission, the prerequisite for that. This is how what you get access to, which is open to all. This is what you get in addition if you are a paid member, the courses, labs community, and access to the Zoom call. This is the course that I'm putting together. This is something everyone will enroll if you have enrolled into a challenge, where I'm writing up the details about what are the topics you should know this week. And I would be adding the projects here. So there'll be 2 or 3 projects this week that you are going to complete in order to complete this week's challenge, right? So to make it interesting, we're adding these, projects, smaller projects, nano project, as I call it. And that's what you would learn this week. And this is what I was talking about. So we are taking up an application and learning how to write the Docker file for it. And before that, I'll be demonstrating another approach where I would create this container image manually as well. So this is the manual approach, and then I can show you how to convert this into a Docker file, what goes into the Docker file, how to use it, and then what instructions go as part of the Docker file. How to optimize the Docker file, what are the best practices. We'll also talk about all those concepts, right? Again, those of you who joined late, I'll take the questions later towards the end. Even if I cannot cover the questions based on the time, I would take it up later and answer it on my school, the School of Devops YouTube channel. So let's get started with this project and understanding of how to build a container image for this. So this is a application, Spring Boot application written in Java. It uses Maven as a build tool. You can see this being Maven here, Maven files, Maven pom.xml as well. This is written in Java application. So you can see the Java source code as well. And this is what you typically start with. So when you are, containerizing your application, you're either a developer who has written this code and has access to it, or you may be, let's say, a DevOps professional who is involved in containerizing the application and given the source code. Anyways, you have access to the source code, and this is what you begin with. And this being a Maven application, a Java application, I would demonstrate the steps related to that when I'm building this, image manually. So when I build this image manually, I start by first cloning the source code. My step number one is to clone the source code. Step number two is to create an environment. The environment is the container by itself with an image pulled from, let's say, Docker Hub or some registry. And this is where you decide what kind of image you want to pull, like whether you want to pull an image which has nothing in it, like vanilla version of an operating system, or you pull typically a base image which contains the build tools, like in this case, Maven, JDK, and so that you save the steps to install those tools, as well as you simplify your process of building your container images as well. You could also build your own images, base images that is, instead of pulling the images from the registry. That's also possible. And that is my step number two. So step number two is where I would create an environment which would be in a container by itself. And then I would copy over my code to this, this container environment. That's my step number three. Step number four is when I will get inside that container and, build the application itself, right? And then once I have done that, I would test it as well. And then finally, after testing, commit the changes into an image. This is my first way of building an image. Now, this is the manual approach where I would follow certain steps, sure. But why do we use this kind of an approach is basically when you write a Docker file, you're automating the process of building an image. So first thing that you should know is the process itself. And that's the process that I'm showing you here and demonstrating to you. And that's when you will want to test build it or manually build it, however you want to call it. So let me first show you by building this container image for this application. So the first step is to clone this code. And that's what I'm going to do here. I can fork this code and create my own copy of it. Or in this case, since I'm not committing anything back to the repository, I'll simply clone it. Where should I clone it now? This is my Docker environment. I can validate by running Docker version. So you can see the client and server both are available. And I have already set up an environment. This is a Linux server, a remote server that I'm connected to. It's running on cloud called as DigitalOcean. And I have cloned this code, clone this repository. That's my step number one. My step number two is to create an environment with the base image that I need. Now I can just take an image which contains Maven. For example, I could go to Docker Hub, search for a Maven image, use this image with one of the tags that suits me, with a specific version of JDK, specific distribution of Java as well, and so on. This is one approach, or this is one image I can take. But in addition to that, for this particular application, there are many dependencies. And when you say Maven, run Maven compile or Maven package, it would take about 20 minutes to pull those dependencies and build this application. I want to save up some time there. So I will pick my base image, which not only contains Maven, but also has the dependencies built in as well. So I'm going to use this image, which has everything here, right? And then I'm creating this environment using a command such as this. So I'm using Docker to run. It's important to know these options as well, -idt. I teach them in my Docker course and so on if you want to learn about it, or just find out the information about what is -i, what is d, what is t, and so on. Then I give it a name. I'll just call it as a dev environment or a build environment. And one important thing that you have to do is make sure that you do the port mapping in advance. Let's say I want to map the 8080 port on my system or a Docker host to 8080. Why? Because this is a Spring Boot application, uses Tomcat as the web server. Tomcat runs on port 8080 that I know about, or you could find out from the application itself. So in the application instruction somewhere, you typically see which port it runs on. It's say the 8080 somewhere. And it's a common knowledge that Tomcat runs on port 8080 by default. So I've already exposed that. This is the image that I pull. This image contains everything that I need: Maven, JDK, the dependencies that the application requires. And I started with something like sh or bash. I'll just start it with sh because I don't have an application to launch right now or to run right now. So I just started with shell and that's it. And this brings up the environment for me. And it would have exposed this port. Once I start the application later, I could test run it. I could validate it that it really works and works, etc. And I would just show you what is on port 8080 right now. So this host 8080, if you're using Docker desktop, it would have been localhost 8080, shows nothing. There's nothing because I don't have the application built and run yet. I do see my dev environment created though. And what I want to do next is I want to copy, I've cloned the source code. Next thing that I want to do is copy the application code inside this environment, because this is what you do with a VM image as well. So you create a VM, you install everything that you need, package your application into it and create an artifact, and then you take a snapshot of the VM. And that's exactly what we are going to do. Similar process, but for the container. So I would copy that code now to that dev environment that I've just created. Where is my code? It's in this directory. I go inside that directory using cd, and then I would use docker cp. Dot is for everything in the current directory. And where am I copying? I'm copying to this environment. So I could use dev as the name, or I could use the container ID and then say copy to some path. Let's say I'm just going to pick one path /app or something. And that's where I want to copy. So this has copied the source code now into this container or called as dev. And now I get into the container. My step number 3 is complete. Now I go inside the container and then start executing the application build, compilation, etc., create the artifact, and then test run it, etc. So from here on, I would be working from within that container. Let's see if bash is available. If not, I'll switch to sh. Bash is available, so I'll use that. I go to the directory where I copied this code. If it did not exist, it would get created when I use the docker copy command, docker cp command, that is. And you see already that path exists along with the code because I had copied it earlier. And how do I build it? Now, this is where the application to application, it would differ what tool that you use to build this image, etc. To build this application, etc. In this case, it's Maven, and I would run Maven package. So Maven has different commands, goals rather. So if you just look up Maven goals, you will find a list of goals, including, validate, including test, including compile, including package. In this case, I want to generate an artifact. I want to compile the application, also generate an artifact. I don't want to run tests right now. I would have done so as part of my continuous integration process already. So I would just package the application. And this is where I would say, okay, Maven, which is MVN, package -d skip tests. This is optional, but it would save me some time right now. Assuming that unit tests have been run already, I'm just generating a package. And this is where it will save me tons of time, since I have that base with the dependencies packaged. It would take otherwise 20 minutes. Now it's going to take less than 20 seconds. So it's building the application, built it in less than 20 seconds, 19 seconds to be precise. And it has generated the artifact for me, which is this application, app, target, and this jar file. So in here, I see this jar file been built, and this is my application. I could launch it just using java-jar. I'm just going to rename it and move it around to another place. So instead of target and let's say Spring Pet Clinic, this long name, I'll move it to run and just pet clinic.jar. That's what I'm doing here. And then I could test run it now using java-jar pet clinic, that is /run petclinic.jar. It's a Spring Boot application. You can see it says built with Spring Boot, which comes with a Tomcat embedded into it. So there's no need to launch it with Tomcat separately. Tomcat is already there and it has started running on port 8080. I had already mapped that 8080 port. This is why it is important to know, in order to understand all of this, it's important to know how the port mapping works with the three different options, capital P, small p. I'm using this option. There are two more options to expose your application using port mapping with Docker. And it's important, if you want to understand how to test it, it's important to have that knowledge. That's why I put it in the prerequisites as well. So the application has come up. This is the pet clinic. You can see the owners, you can find those. So there's some database. It's just an in-memory database called as H2, and but it's all working fine. So since my application is working okay, I'm at the step number 4 and 5 here, where I've test run it. And since it's all running okay, now I can optionally commit this into an image as well. I can create an image without writing a Dockerfile as well. This is the way you do that. And I will exit. To create an image, I would exit out of that container. I'm back to my workstation where I have this container launch from. And then I could take all these changes. You can in fact do a Docker diff, just like git diff, what all changes you made after launching the container. You can do that or check that use Docker diff as well. This is like git diff. And just like git commit, you can do a Docker, but it's the container that you're committing. And you can pick up the container ID or the name. Either of that will work. I remember the name, so I'll use name of the container called as dev, and then I'll create my own image. When I create my own image by committing, I would use my Docker Hub ID, my Docker Hub username. Even though it will not validate right now, if I try to publish this image to Docker Hub, I will show that by publishing it just after this, it would validate, it will try to validate my username, etc. at that point of time. Your username, Docker Hub, Docker ID it is called, or Docker Hub username is always in the small characters. When you log into Docker Hub, you see that on the top right corner. I see that being initcron. So this is my user ID. It could be your organization name or project name, just like GitHub. And then I would create my very first version of this application, Pet Clinic. And I'm committing the changes that I've made to the container called as dev. I don't need anything else apart from that. And I create my own image. This is my own image, which you see here. I've listed this, and this is about 782 MBs. Later, I'm going to show you how to optimize this further. You can bring it to 1/5 of this or even less than that. It's possible. There is some technique, and that's why I call it as the art of writing Dockerfile session, because we'll create an optimal Dockerfile later. Let me show you what is there in that though. So I've used Docker image history. This is a command I love and use very widely. A very useful command to know how many layers are there, what layer does what, how big is that layer, and based on that you can further optimize it as well. So you can see these are my dependencies. This is from the base image. Base image started with some base operating system. On top of that, there is JDK. On top of that, someone built a Maven image. On top of that, I have added my own, let's say, dependencies, which probably is about 200 MBs. And now the application is about 60 odd MBs, right? And together it becomes 782 MBs. How are these layers created? I'm going to explain that to you as well. And that is the secret behind this is Dockerfile, the instructions, right? But since I had created this manually, I just have one layer of mine. Everything else is from the base image, right? This is the manual way of creating this image. I could also publish this image to the registry by using Docker image push. So just like git diff, git commit, git push, we have Docker diff, Docker commit, Docker push. And then I provide the tag, which contains the username, the repository name, and the version, or also called as tag. And once I have published it, has it been published? No, it says denied. And this is what I was talking about. So it will try to validate, it will try to authenticate and authorize you. In this case, my authentication has failed, so I have to do a Docker login. Docker login doesn't mean, once you're logged in from the browser, doesn't mean you're logged in from the shell as well. You have to log in from here as well. And once I have logged in, I can publish that image. If you look at it, it does not push everything, like not that entire 782 MBs, it's just pushing 60 odd MBs. Why? Because there's only one layer changed between the base image, which is already part of Docker Hub. That's where I pulled it from. That's why it says layer already exists. And then there's only one layer that I created, which was about 60 MBs. That is the only thing which got pushed. And this is why it is important. If you want to understand this, it is important to know the basics. That includes your union mount or overlay file system and how does it really work? What is the overlay file system? What is the union mount? Also, what are namespaces, C groups? So those are the fundamental concepts everyone who's getting started with containers should know about. Now, I've created this image manually. Let me demonstrate to you how it would work when I have a Dockerfile instead. What is Dockerfile? Dockerfile is nothing but you take these instructions, convert it into a code, and that gives you this Dockerfile. Before I show you or start diving into the instructions and start showing you how to write one, I'm going to use this Dockerfile, which already is present, right? And if you read this Dockerfile, let me add it first. Where do you add it? You add it in the same directory typically where the source code is. So this is where I create the Dockerfile at. All right. And you can see, even if you may not be aware of the instructions, you can start figuring out what's going on here, right? So I did the same thing earlier when I did this manually. I started with this image. I copied the code to this directory. This is being created here. The copy seems to be there. Then I run the same instruction. There's something else for bug fixing on Windows, but otherwise, this is the instruction that I run. And then I copied that file just like I'm doing it here. And then I launched it to test run it using the same command. So similar thing, you know that this runs on port 8080. So there seems to be some metadata as well. So let me feed this to a automated process, which is going to be my Docker image build command. And this is where, this is how I use it. So when I provide that as an input to the Docker image build process, what I get as an output is a container image, the Docker image. That's what I'm going to demonstrate to you now here. So I have the Dockerfile here with the default name as Dockerfile with only D in capitals. And then I would say Docker image build -T. And then I would take or provide the tag, -T is for the tag. This time I will use version 2. And then finally provide the path to the Dockerfile. When you run this command, one common thing to omit, common mistake, is to omit the path to the Dockerfile. It's also called as the build context, which I'll explain to you later. But this is what was omitted. And if you omit this, you get an error like this. If you see error like this requires exactly one argument, you've forgotten the dot, which is the path to the Dockerfile and the build context. And it starts building. Now, if you observe, it's just automating the process of building that. I don't have to do anything. It's creating the intermediate container. It has copied the code. It has started building. You see that happening right now. And it's going to give me an image which is ready. That's exactly what is happening right now. So you see the image has been built and it's already been tagged as V2. Let me show you the difference between V1 and V2, right? And you'll start understanding the significance of Dockerfile through that as well. So I have the image V1 and V2. Both are identical in size. So is there any difference? Let's find out. The real difference you'll start seeing when I run Docker image history with V1, which you have already seen, and V2. Now you would see the difference, and you can see already there are like 1, 2, 3, 4, 5 layers, not just one layer. This had only one layer, right? Everything is from the base image. The base image layers are still there, But on top of that, you have 1, 2, 3, 4, 5 more layers. Where do these layers come from? And the answer to that is the Dockerfile, of course, because you can count the number of instructions in the Dockerfile. How many instructions do you expect to see? You can put it in the chat actually. How many instructions do you expect to see in Dockerfile with the 5 layers? What's your answer? 5 or 6? You may have expected 5, but there is
5.
All right. It's actually 6, Rajesh. So why 6 is because you have from, which brings the base image, right? So all these layers came from there. So you have all those plus everything else gets converted into the layer on top. So you see work directory, you can see that, clearly see that work directory, copy, run, export CMD, and you see work directory, copy, run, instruction, expose, and CMD. All right. So how did these layers get created really? This is where it gets really interesting. I'm going to show you that first, an iterative process, before I actually dive deeper into the art of writing Docker files, etc. Right? Because this is where it gets really interesting. It's a very interesting concept. So how the images get created, the layers get created is very interesting, because what happens actually, let's say you have this Docker file. I'm unable to connect my iPad today. Otherwise, it is more interactive and it reveals one step at a time, which is even more interesting. But since that is not working, can I try one more time? No, it's not working. So I have to rely on my PDF document, PDF version of it, which reveals everything at the same time. But nevertheless, what I want to demonstrate here is this is a Docker file. This is what we start with. And we feed it to the Docker image build process. And what happens here is it takes that from instruction. Let's imagine your base image had 4 layers. Okay, your base image had 4 layers. It starts with that. And what it does is it creates that intermediate container. Just like how I did here. I created that intermediate container as step number 2. It's doing that here by using that from base image from defined with from. And then what happens is it executes the work directory, meaning it creates the work directory. And then what happens is even more interesting, is because it commits that immediately. And that's when you would have gotten this layer, work directory, right? This is when the work directory layer is created. And then it basically removes this intermediate container. This is an intermediate container. It gets removed after committing this change. And then it takes that as a base and launches another container. For copy, it doesn't have to, but my initial thought was it does, but for everything else, it does. So it launches a new container, imagine that, and then executes the next instruction, let's say copy, and then commits that into a new layer. This happens for every layer, including copy. And then that process continues. So this is where you got the 6th layer. This is what you get. You got the 5th layer and the 6th layer and the 7th layer. And you have this iterative process where these intermediate, containers are being created and being deleted constantly. You can actually see this in action. It's just that we don't pay too much attention to it. But when you see Docker container run and image build rather, you already see that here. So you saw here that it started with the from, and it run this, created a new container here. Or it created a new, it started with this image rather, and then it went to the work directory where it created the container. So when it says running in this, it's that intermediate container. It's that intermediate container when it says running in this, and then it commits that and removes the intermediate containers. You see this removing intermediate container also. And then it commits it into that image with the new layer. So this is the image, and the image ID is here. And then it copy doesn't do that. Copy doesn't need it. But then after copy, the run instruction does that. So it says running in this. So it has launched a new container. It has run that build command, and then it has committed that into a new image, and it has removed that intermediate container as well. And it follows the same process. Running in new, this is a new container, executed the expose instruction, committed that to get that new layer. And it follows the same process until it exhausts all the instructions that includes from, work directory, copy, run, expose CMD. Once the CMD is done, which is here. After that, it marks that final image with the tag that you provided. All the intermediate containers are gone. They were used during the build process only. And once they are gone, the final image with all the layers is what is tagged. And that's exactly what you see here, being my final image with all these layers. So what is the secret of these layers? It's in that iterative image build process. How many of you did not know about this process? Put it in the chat. You're there on the live stream also. So for how many of you, this is new process? Because, when I show this, a lot of people discover this for the first time, but it's a very interesting process. And this is all cached. Not only that, it's very intelligent. It is all being cached as well. So when I run this build again, it doesn't do everything, or it doesn't do anything really, because it says using cache. In fact, when I show you this build process, I'm going to show you at least 2 more times. You will discover some new things every time, right? So every time I show you in the same output. And that's where it gets really interesting. So it is important to know this process for a couple of reasons. One is, this is going to explain to you how the layers are created, how do you optimize it, how do you right size the layers, etc. And also this is very useful for debugging, because when things go wrong, you can debug using, let's say, the image which was created just before the last error. Let me show you that. So the image which was created just before the last error could be this. And I'm introducing an error here. And if I try to build, it doesn't work. It failed at step number 4. But until step number 3, everything was committed successfully, which is available in this image. Look at this image, 411 ending CFF. I would see that now. Since it failed, I do see that now, 411 CFF. So everything till that step is already available, and I can run a command container like this, docker run -it -array. I'm just creating it temporarily, so it will get deleted when I stop it. That's what I want. I take this image and open a shell, and you would notice that the first 3 steps, copying the code, creating the work directory. Work directory is there. I'm already landed up in the work directory. Do note, make a note of that. I'm in the /app directory. The code is being copied already. So everything till that copy command is being executed. And then I can just figure out, oh, what's wrong with this command, where it tried to run this particular command. And of course, this is not a command. So you can figure this out, fix it, and then go back, make that fix, run it, run the build again, and you're ready to go. So it's quite useful to debug things as well. And from that point of view as well, this is quite important to know about the iterative image build process. Now let's get to the Dockerfile and the instructions, because this is where I talk about how do you optimize it, how to write the instructions. And we're going to reference this Dockerfile, which contains from, work directory, copy, run, expose, cmd, etc. Right? We look at each of these instructions plus a few more and try to understand what is the purpose of each of these instructions and how to use it. What are the best practices related to each? So Dockerfile, as you might have figured out already, is a declarative text configuration. You can call it as a code, which can be shared, revision controlled, can be used for automation as well. The syntax that it follows is very simple. It doesn't follow any YAML, JSON, Node, or Java syntax. It has its own simple syntax where you have instruction followed by arguments. It is a convention to write the instructions in capitals, like run, from, cmd. It's a convention. It's not a rule. It's a best practice, right? So you can still write it in small letters as well. It will work, but it's quite difficult to figure out or differentiate the instructions from the actual argument. So it's a good practice to follow this convention. Let's look at some of these instructions, starting with from. From is the base image. You always have to define or start with some base image. Even if you build your own base images, you have to define that here. You have to have some base to start with when it comes to building your application images, building, containerizing your application. And it follows the same pattern of you have 4 different fields in an image, registry. So when I say an image, even if I have an image like this, so I can use docker run -idt Alpine sh. In this case, Alpine is an image, right? Now, this actually has 4 different fields. I can actually see it. It's just hidden. It's implicit there because this translates into docker.io, which is the Docker registry. The registry name, the namespace is library. You already see that on the top, and the version is latest. So even if I see just Alpine, you can figure out, or you should be able to figure out what is the tag, what is the namespace, and what is the registry. You can already see it here, or when I pull the image, you'll typically see it. So it belongs to library, Alpine, the latest version. It belongs to docker.io. Even if you pull the image separately, let's say Docker image pull, let me pull an image for Ubuntu. You'll see the tag being latest. The namespace would be library. And you'll actually see this time the fully qualified name of the image, docker.io, library, Ubuntu, latest. So you should be able to figure that out. And those are the 4 components which go as part of the from. From becomes the base for everything else that follows, right? So we already know that. So it's an iterative process. It starts with from, it takes that into a new image, and the new image, and the new image, and the new image. Unless it hits the next from, which I'll talk about a little later in the multi-stage Dockerfiles. The next instruction, which is the core of the Dockerfile, which is the run instruction. I'm also going to show you one more Dockerfile from Docker Hub. And the one I reference commonly is the official version of MySQL image. And you can find the Dockerfile by going to the description of that image, the official version of MySQL, and just go to any of this and it will take you to the GitHub source code for that Dockerfile. MySQL image or the Dockerfile is full of all interesting instructions. Of course, including run. Run is the core of it. In this case, run is being used to, define how to install MySQL. And the instructions are all given here. You can already see this. And let's say you see that there, you'll see a pattern where you'll find a few run instructions and a bunch of commands are combined into one single run instruction, right? So you see a bunch of commands combined with semicolon and this backslash. Sometimes you'll see and backslash and on either side of the backslash and so on. Now, what do you think could be the purpose of combining all these commands into run instructions, one run block? Why not use multiple run instructions, one run instruction per command? That's a question. I want you to think about it, since we are doing a live stream and not a lot of interaction right now. Think about it, and I'll talk about why this is the case with an example, actually, right? So some of you might have figured this out, that it is because of the layers, right? So the number of layers as well as the size of the layers. It has 2 consequences on the number of layers as well as the size of layers. Does anyone know from any of the live streams or from the Zoom meeting, anyone knows how many layers can a Docker image have? Maximum number of layers. Any guesses?
30.
20, 30. All right, that's common. Sure, but there's a limit on the number of layers, which is about 128. That's the total maximum number of layers you can have. That is the address space, basically. The address space being used for the layers, for the overlay file system, basically, because it all translates into the overlay file system earlier, ultimately union mount or overlay file system. That can store up to 128 as there's a limit on that, the 2 raised to, I think 2 raised to 3 or something. So so it's basically the 3 bits address space, basically. If you look at that octet, so maximum you can go is about 128, and that is one aspect of it. The second aspect is it also has impact on the size of the image as well, size of the layers as well. How do you write run instruction? This is one of the key concepts to understand in order to optimize the Dockerfile and the size of it and the number of layers, etc. So let me give you an example here, right? So The example is, it's a 3-step process. I have to install an application with. First, I download the application. Next, I would install or extract it. Number 3 is I would delete the downloader. And I could write it in 2 different ways. One is, this is our optimal way typically. This is another way we can add a run instruction for each of the step here. Now, if I do this, what happens is it downloads the file, commits it into a layer. That is the problem, because now this is permanent, right? Gone into that image permanently. Then in the second step, I would extract it and install, which has a downloaded version and an installed version. Number 3 is where I would have deleted the downloader and just have the installer part. Now, even though that file won't be shown when I launch a container with it, it is still there, committed, and there's a redundant copy sitting somewhere in that image, bloating that image as well. So this is not really ideal. Whereas you see this, where you download, install, delete the downloader, and just commit the files that you need. And this is exactly what you see here as well. Look at the MySQL installation. You start with generating apt-get, update, package index or cache as well. Even that index is being deleted later. You can see that being deleted somewhere here, right? And then you install MySQL. Then you start cleaning up. So this is where the index, package index is being cleaned. This is where any MySQL files which are not needed, apart from maybe just the binary and the libraries, you remove those files as well. So everything else is being cleaned up, and only the MySQL binary essential components of it. And that's all is being committed as part of this layer, right? So this is something you should understand very well. And secondly, what you should understand is what also happens is, whatever changes often, let's say you're going to install MySQL every time there's a new version. That's what you're creating this image for, different versions of it. Now, anything that changes like that, right? So you should put it towards the bottom of the Dockerfile. Why? Because this is another key technique, because that is going to lead to the top layers. The bottom of the Dockerfile will translate into the top layers, top few layers. And what happens is, if you make a change to a layer, it is not just that layer. Anything that follows also will get recreated, meaning those many layers to distribute and update unnecessarily. If you have not made any changes to anything else as well, it will get recreated. So if I had this instruction towards the top of the file, I would unnecessarily also recreate these layers. These layers typically do not change. Almost never would you want to change the user management and this configuration and repository configuration. You don't change that. The version comes in and automatically is available in the repository. So even repository configuration doesn't need to be changed very often. The MySQL may change, and you only recreate that plus any other typically metadata and other layers which don't matter too much in terms of the size. So those layers are okay. So anything that is in flux, constantly changing, dynamic, you put it towards the end of your Docker file. So the top layers, translated in top layer. That's another technique you should remember. Moving on to the next instruction, which is the work directory. All right. If there are any questions from anyone who's joined Zoom, just interact. You can stop me anytime and ask the questions verbally. Just letting you know. I'll be taking questions on the live streams a little later though, since I cannot focus on everything here at the same time. Okay, work directory is another instruction which is quite useful. And you see the work directory being used by us to define this directory /app. And this directory will get created automatically. That's number one. Even if it is a multi-level path, it will automatically get created. Like XYZ/ABC and all that. So the entire path will get created, including the parent directories. And what is the purpose of work directory? Work directory is something which will be used everywhere else that follows, like copy, run, command. Where are these instructions running from? They're running from the work directory. That's why you don't see the CD business in Dockerfile. Sometimes I see people adding, let's say, CD/app unnecessarily, probably because they don't understand the work directory, but that's one of the common mistakes again. So do not worry about adding CD instructions. you basically just define the work directory. You can change the work directory later, and from that instruction onward, it will apply that particular work directory concept, right? So it's an important concept, very useful. And even when you launch the container, when you land up in the container shell, you're on the work directory. And let me show you that here. So if I probably have run one of these containers and have defined a work directory with that, or not. Let's say docker run -idtp. This is my v2 version of the application. And when I get in to that container created, starting with bf, you will see I'll land up in the work directory, which is /app. So even when the container is launched, what you land up in is the work directory. So work directory is quite useful and important. Next instruction is add a set of instruction, add and copy. And copy gives you a way to provide the source code to while building the image, basically, right? So whenever you run instructions and all that, it needs source code, like compilation that we did with Maven compile or Maven package. It required the source code. How did the source code get copied to the build container or that dev environment? Was via the copy instruction. Now, when you see copy instruction, you only see dot and dot here. What does that mean? What that really means is we are copying using relative paths, and these paths are relative to two different things. The destination is relative to the work directory. So where the code is going to get copied in the build container at /app directory. That is the destination because I've used dot here. Now, am I copying from the same path? No, because when you define the source, it is relative to the build context. Now, what is this build context? Remember, I talked about the dot. You shouldn't forget the path to the Dockerfile. That's also the build context. Look at this now. I'm pretty sure a lot of you might not have observed it earlier. When I build the container image, the very first thing that happens is it transfers the build context to the Docker daemon, right? What is this build context? Build context is whatever I defined in that dot, the path, and this includes the source code. So everything is available for the Docker daemon for it to be considered copying. And you can copy everything using dot, or you can be selective with only certain set of files. Let's say I just want to copy these three, one directory and two files. I can do that by using something like this. So multiple sources. So this is one directory, maybe this is a directory, there's a file and the file, and the destination remains same. So you can also use this to selectively copy the files. The second thing you should remember is the build context is typically your subpath of the source code. Because what can happen is, and this is a common mistake, is you put the Dockerfile in outside directory, let's say in your home directory. And I've seen this happen where there was a case where it took longer. It used to take longer, like 10 minutes, and then it would run out of disk space. Why? Because the Dockerfile was put in the home directory, which was more than 10 gigs, and it was trying to copy that entire 10 GB to the Docker daemon, which is typically your VM sitting in your host or so. It's a limited environment, and it would take forever. That's one. Second, it would run out of disk space. Even if that is worst case scenario, even if you have some redundant unnecessary files in that directory, every time you're building, it is getting copied to the Docker daemon. Imagine that, right? You don't need that happen. So typically it is the build context is typically where your source code is, the root of that. That's where you should put the Dockerfile. And that is what you typically provide as the build context. So when I copy, I use copy dot dot, which is my build context, which is the place where my code is, source code is, the same directory where the Dockerfile is as well. What is the difference between copy and add though? Add does two more things additionally. One is add does, remote source as well. Add accepts remote source, that's number one. Number two is add can also extract at the destination. If it is an archive like zip, tar.gz, something on that line, it will not only copy, but also extract it at the destination, right? And then that is the difference between copy and add. Mostly it is copy that you use. Next instruction is env. Again, you see that being used here. Env defines the environment and that is available during the build process. That is also available during the runtime. Any environment variables that you want to provide during the build, during the run, you can do that as well. In addition to the environment variables, during the build, you can also provide arguments, runtime arguments called as ARGS, right? That's another thing which is similar. The difference though is you put the environment in the Dockerfile itself, and you can change the version, a number, etc. And anything that you need during the runtime as well, you can put it as an environment. Expose defines what port your application is supposed to run. And expose can take multiple ports as well. We defined 8080 being the expose port. That is the port our application runs on. And this is useful for the consumers of your image to know what port to map and to make it easier for them to understand. And you can also use that capital P option. So if you look at it, the way I launched it is IDT capital P, right? This is another option from the port mapping triad that I call it, right? So the capital P, small p, there's another version of small p, and so on, right? So this is a capital P, and this reads that exposed port automatically. Whatever port you expose here, it will be right there. Sometimes you'll see multiple ports being exposed. Is this a port mapping that you do during the launch time with small p and so on? It's not really that. It just defines two different ports that application listens on. A good example could have been port 80 and 443, right? 80 for HTTP, 443 for HTTPS. Same application listens on both ports with two different protocols and so on. So that's the exposed instruction. The next instruction, also very important, is command. And this instruction is not activated during the build. During the build, it does nothing. There are some instructions which get added as just metadata. Expose is one, which is used during the launch time. Also, the command. Command defines what application, how to launch your application when the image is actually launched into the container. That is this command part, right? And this is not used during the build, but when you create an image and launch that, what gets launched is defined with the command, right? And sometimes you see multiple commands as well. So this is what launches. So that's why I didn't have to provide the application name or the command when I used Docker run here, because it takes that command automatically. I can override it, of course, but this is the default command. Sometimes in the image, when you look at the image history, you'll see multiple commands. This has 4 different commands. There's one here, there's one here, there's one here, there's one here. What do you think would happen? Which one would it run? It's actually, containers are created to run only one command at a time, and it's going to pick the latest one, the one you created as part of your Dockerfile. Everything else is ignored. Why do you see those though? Maven and JShell and so on. This tells you the history of the image as well, because it was created with this as a base, and then it picked up this while installing Java, and then Maven, and then it added. So there are multiple images which have been iterated over it here, and that's why you see multiple commands. So if you picked up Maven, it would have run this command. If you had picked up Java image that it used as a base, it would have run this command. If you had picked up the base image, maybe just the Ubuntu or CentOS or Alpine, it would have picked up just this bin bash as the command. That's why you see those many commands, and only one command, the one you use, will be picked up. Also, you define the command in a way that the application is launched in the foreground mode, because Docker has to attach to the application and it has to run in the foreground for that purpose. That's how Docker is able to fetch the logs, able to control and restart the application, etc. That's the command part. And if you know the command well, there is something else which is added for confusing you, which is entry point. And how does this work is basically, I told you that command will be launched or used during the launch time when you launch it into a container, unless there is an entry point. Because if there is an entry point, it will first take over. The control will go to the entry point, and then optionally you can call the command. What is the purpose of entry point? Let's take an example. That's why I've taken the MySQL example here, because it also has that entry point. Entry point is being copied from here to use a local bin. And then entry point is a script. If I want to understand where it comes from, it is with respect to the build context. So same path as Dockerfile. If I want to find that, I can just go to the root of this. And this is where I see the entry point. What is entry point doing? You'll see entry point doing a bunch of things, including, it looks like a long, very long script, but that's just the nature of this particular application and the script. But entry point don't have to necessarily be this long. But what does it do? It sets up the root password. So anything that I don't want to provide in the image, let's say I don't want to hard code the password into the image, of course. So we want to define it during the launch time. So it takes the environment variable in terms of the password as the environment variable, and then it would launch that, create the password, etc. And it does a bunch of other things before actually launching the application. This is an entry point. So you launch the container, entry point comes in, it does the initialization, like setting up the admin password, creating the users, initializing databases, setting up grants. That's the way MySQL authorizations are defined. And that's what you see happen here. So it sets up the password, sets up the, creates the databases, generates that, sets up the grants. It does a bunch of other things, alters users and stuff like that, right? So it does all of that, and then finally passes the control to the command using exec $@. $@ is set of all the arguments. Why set of all of the arguments? Because you can have your command defined. Command is passed on as an argument to entry point, and your command itself can be a bunch of arguments. In this case, it would have been argument number 1, 2, and 3. So all these 3 make up my command, and that is being launched with exec $@. And that is why I say from entry point, it can optionally, that's why I have this dotted array, it can optionally launch the command, right? In this case, MySQL. So what is the best practice here? So my recommendation here is you use the command always. And when you have to do something before launching your actual application, you can use the entry point for that purpose. That's my typical recommendation to you, right? And that's about it. And there are a few other instructions. We're not going to go too in depth into it due to the time constraints. But what I'm going to talk about is another interesting thing called as a multi-stage Dockerfile. Before that, let me also show you how to write a Dockerfile as well. And I'll take up a project and do it for that. So I'm going to take a project, and this is part of your challenge as well. You're going to get access to this challenge probably tomorrow. And it's going to use a C application, and you're supposed to write a Dockerfile for that. Just pulling that up. Let's say this is the project I want to containerize. Again, I've been given the source code. It uses Ubuntu as a base. It would need to run these commands as the packages, the build tools basically, and then I would run it with make all because it's a C application, has a make file, etc. And the application comes up on port 16,000 and so on. Now I would typically start testing this manually by creating a Ubuntu container, copying over the code, installing these, and then building it and all that. But I know the process, and I just want to show you how to write a Dockerfile for it, right? So I'll just skip to that part where I write the Dockerfile. So I would begin by first cloning the code, of course. That's my first step, always. And that's what I do here with git clone. Now I want to create a Dockerfile for this application. So I begin by writing Dockerfile with a typically there are a few instructions which are very common. You start with from, which is a base. You define the work directory, useful thing to do. After you define the work directory, you will typically copy is ... most of the time. And then you have some run instruction, you have expose instructions, you have command, and then follow the rest of the things like entry point and whatnot. So I don't want to define the entry point. I just want to write the command cmd. and that's it. So what do I do here? From what? It's all given here as part of the description. Let's say this requires you to launch it with, or at least the instructions require you to launch it with Ubuntu. So I can just say Ubuntu, as the latest version of Ubuntu is fine. Work directory would be something like, I'll just define something to start with. Copy is going to be almost identical, copy dot dot. Then comes the run instruction part. Earlier, I had shown you the Java application, which had only one command, one or two commands, Maven compile, Maven package. Here, I would have to run something like this, apt-get install, before that apt-get update. And then I'll have a new command. So I go to the next line and then next line. This is typically I would do it. And the next command involves. So there is no sudo within the container. So when you do it manually, you will understand all this process. And another important aspect is when you install something, you have to make sure it is non-interactive. It shouldn't ask you for any user interactivity, etc., because you're scripting it. And it installs build essential, will bring in all the compilers, make these are the dependencies for the application. And then the application runs on port 16,000. I would also have to build the application, of course. So that part, I can put it here. Make all. Or to optimize it, I would actually, as a best practice, I would use one more run instruction and make all. So I told you that you can reduce the number of layers if you combine a bunch of instructions into one run. Then why am I creating another run instruction for it? If you have guessed it already, or basically I'm trying to avoid recreation of this layer multiple times and unnecessary things going into that layer, because I would, every time there's a code change, and that would be the most often thing that you would change. You are also, if you combine it here, you're also installing those applications and those packages every time there's a change, right? Because when it detects a change in the code and when it builds that layer, if it is combined, it would also create a larger layer with a lot of redundant, unnecessary changes rather. In this case, it would just change the code and the artifact that it generates, and that's it really. And that's what I want. And bin Facebook. So you have to balance the number of instructions with the rework that you would do, and you'll have to come up with your optimization algorithm accordingly. This is how the application launches bin Facebook. It's given here. So I'm just saving up some time here for brevity, because these are generally 4-hour sessions that I do, which we are trying to compress in 1.5 or so. So Docker run, Docker build. I'm building this image, -t, Facebook, version 1, and building the image here. All right. It started with the base Ubuntu. Image was already pulled as part of my previous command, defined the work directory, copied the code there, started installing the base. That's what is happening right now. The build tools rather, that's what is happening right now. And then it goes and compiles the application after that. So that would happen in a few seconds. It's still building, still pulling the packages. This is the time when it is compiling. You may see some warnings because it's a older application comparatively, but it is compiled fine. It's all right. And I have the image, which I can see here. Let me check the layers and the size of the image. So I will begin by listing the image, which is about 396 MBs. I'll show you how to optimize it also shortly. And then Docker image history of the image shows me there are these many layers. A majority of it is basically the apt-get update and install the build tools, right? You also have something else, which there are at least 2 things which shouldn't be there. One is the build tools, which shouldn't be there in the final image. You just need the runtime, so your application and the libraries. That's all. So build tools are unnecessary. How do we get rid of that? I'm going to talk about it. There is one more thing I want you to figure out, which shouldn't be there as part of this final image, but it is part of it right now. So if you can figure it out, put it in the chat. I will answer that in a couple of minutes. But I have this image ready, and let me show you by launching it. So docker run -idt capital P. The image command is already defined, so I don't have to provide anything. Port mapping is already there, so that's why I'm using capital P, so that it automatically does the host port mapping to the container. All of that is part of my Docker run and operate course or chapter if you want to dive deeper into it. So it has done the port mapping. 49154 is the port. So if I go to that host 49154, I have the application running, which means the application is built fine. It's launched fine. And yes, this is the best social network you've never heard of. Jokes apart, this is a very interesting application to build an image and experiment with it. And I have an image which is about 400 MBs worth. I've already talked about it. So these are the layers. This is the image. What do we reduce this to? You will be surprised. What is your guess? Like if I optimize it, what is the smallest image that you can get? What would be your guess if you have to take one right now? Just put it in the chat. All right. Let's see. Let's find out how small we can go. And one thing that I've talked about was the build tool shouldn't be there. The second thing, some of you have already put it there, it's the code base, the code, source code. Source code shouldn't be there as part of the final image. How do we get rid of it is where earlier there used to be a challenge because you'd either write two Docker files, one to build the artifact, and copy it to your workstation, second to take the artifact and package it with the runtime, or you'd have this bloated image, which you see right now, which is about 396 MBs. And it's difficult to get rid of the source code, the build tools, because source code got committed at some point of time. And even if you delete it later, it is there in the bottom layer somewhere. So until Docker created this solution, anyone knows the solution for this and how do you optimize it, or what would be the ideal solution for this? Docker created this solution around 2018, but before that there was a problem, a real problem, and that solution solved a lot of people's problem. And that is called as not Docker Compose, but multi-stage Dockerfile. Yes, so I see Rajendra has guessed it right on the chat. Some of you, a lot of other you might have already guessed it as well. So it's a Docker, multi-stage Dockerfile, sorry. So multi-stage Dockerfile, how does it work? You typically see two or more stages. I'll show you an example of that. If I have to build a Java application, or let's just take this Facebook application. Let's look at a couple of examples here for multi-stage Dockerfile. And the example that I typically use is, this is the Facebook. And then there is one more, yeah, Sysful. This is a Java application. I showed you an image for Java. That's why this would be easier to understand. And there's another Java application, uses Maven as a build tool, but it would require Tomcat to run it. It's not a Spring Boot. So you see two stages here. What is the purpose of two different stages? How do you identify two stages? You look at the from instruction. If you see multiple from first from to the next, there is one stage. This is stage number 0. This is stage number 1 implicitly. You can also name it as build, as run, as whatever you want. And how does it work is basically, let's look at what do we have right now. As part of our single stage Dockerfile, there is the base operating system plus the build tools, source code, runtime, and the application. What we need is the application, the runtime, and you inadvertently need the underlying operating system as an environment, root file system at least, right? Even if it is stripped down version of that. You can get rid of the build tools and the source code by using the multi-stage. And how do we do that is the first stage that you see, stage number 0, is where your build tools are, and that's where your source code gets copied. And that image that is being built is never published. It is just used as an intermediary to give you something like artifact. In this case, The example that I show you, the artifact is a jar file. There's a jar file or war file in this case. The whole purpose of the stage number 0 or build stage is to generate the war file. And the next stage comes in with a new base, so fresh image, which will contain only Tomcat, and you're explicitly copying one file from build, reference this. This could have been from 0 as well. And you're copying only one file, that's this war file, to web apps directory with Tomcat, and that's it. That's all you have. That's all you get here. And this is the final image, which only contains your, so this intermediate image is gone. It is unpublished, untagged. And this contains the application binary. Yes, that's the whole purpose we use this stage for. And then source code, the build tools remain here. And we explicitly copy application, install rest of the dependencies, and package this as the final image. So you can use this technique. So you can use this as one technique. Second technique is using an optimized version of the base image. A combination of that can give you a really, really tiny image. I'll show you how tiny it is. For this Facebook application right now, we're at approximately 400 MBs mark, 396 MBs to be precise. Let me show you how small you can go with it with an optimized version of a Dockerfile, a multi-stage Dockerfile. I already have it. I'm just going to demonstrate it to you right now. And I add it as a dockerfile.ms multistage. So see, 2 stages uses the same base. Why are we doing it in 2 stages then? Same image, because we are excluding the source code, which is being installed here, added here, and the build tools, which are being added here. This SDK, which is about 200, 300, whatever. We'll find out. And we are excluding that and keeping only things that you need, like from build is this. We are copying just the binary. Static and templates are needed to, render those web files and so on. And then we install just the dependencies explicitly, in this case, just SQLite libraries. That's it, right? This is what gets me my final image. Let me show you how this works when you build it and what to expect and how small it goes. So I'm building this now using Docker image build -t v2. There is one problem here. Has anyone noticed? This is not correct. It would build an image, but it will give me the same image as earlier. What am I, when I created the Docker file this time, I used a different name. If you use a different name, apart from Dockerfile, you have to provide the file name as well. That's an important part. I'll add it after Docker image build as an option. And this is gonna generate a 2-stage, this is a 2-stage Docker file. So it's gonna create 2 different images and tag only the one that I need with everything that I need. So you can see the step number 1, 2, 3, 4. That's part of the stage 0 or the first stage, compiling the application, done. And then it starts with a new image, same base, sure, but it's a fresh image, a fresh container with using the same image, right? And then it adds the work directory, copies the files, and that's all it does. And it's a working image. Let me show you that it actually works. Docker run -idt capital P. And it's running on 49155. 49155. So the first test, pass. It is working. It's a running application. So everything that we need is there. We validated that. Now is the time when we see the magic. And if you get how small it is, we started with 396 and we ended up with about 8 MBs, 8.29 MBs to be precise. Like, so that is how small you can go, provided your application is tiny and the runtime it requires is tiny. Because sometimes you have the base itself, like you need Tomcat, and Tomcat itself is 200 MBs. You can't do much about it. But in these kind of scenarios where it's a tiny application, it's a compiled application that is C, and you can do with something like Alpine, just you need a Linux environment, which is absolutely fine. Alpine image is very small. That itself is 7 MBs. You can see that. Compressed version is around less than 3 MBs on Docker Hub. But that's that. When I push this to Docker Hub, it would be even smaller. So you'll see that Docker image push. So when it gets distributed, it's really, really efficient if you do it this way. Because it compresses. Docker has a very good compression algorithm, and this 8.29 MBs shows up as how much? Let's find out. Let me go to my images. The latest is this V2. And you can see the V2 version is about 3.84 MBs, so less than 4. That's how small you can go with the multi-stage Dockerfile in combination with a tiny version of the base image, right? And that's what I wanted to demonstrate to you, the advantage of using multi-stage Dockerfile. How do you write the Dockerfile? We looked at some of the key instructions. I also demonstrated building images for a couple of different applications. I demonstrated writing a Dockerfile very quickly. You can find a more elaborate version of all this demonstration, etc., in my courses as well. But that's what I wanted to demonstrate to you in the form of this quick, understanding of the art of writing Dockerfile, how it really works, what are the instructions, how do you go about optimizing the Dockerfiles as well, using multi-stage Dockerfile, using a base like Alpine, which also gives you a secure, it's not just smaller, it's also more secure because less number of packages translate into less number of vulnerabilities as well. All right, so I'm going to just take up some questions now. Are there any questions from the Zoom room from the members? I'll also be talking about how do you get access to the challenge. And I'll also be talking about the membership in case if you're interested to go and learn about this and dive deeper using a structured approach. You can always find a lot of resources which are available over the internet, over YouTube and otherwise, but this can give you a sort of a fast track process to learn things faster with the least amount of time. So I see some questions on, let's say, the YouTube live stream. And there's one question about, okay, Vinayak says, amazing session, thank you. Betula says, how can I access the challenge page to understand the prerequisites? So if you have not joined the challenge, you go to basically devopsclub.co/Kubernetes. I assume that you already have enrolled to this. If you haven't, this is what you begin with. This gives you the form to fill in with your email and you get added to the challenge. Now, once you have been added to the challenge, how do you get access to this page and everything else that I would add to the challenge in terms of, this is where I'll add the description of the projects and all that as well. I'm writing that right now. You would receive an email with the access to enroll here, right? So you're going to receive an email at the maximum tomorrow evening my time. You would definitely receive an email about it, and you will know how to get started with the challenge. And you will have a 1 week time from now to complete this. So until next Wednesday, let's say, because we're going to do the next live session on mission number 2, that is about Docker Compose, most likely next Thursday. I'll confirm that because I'm traveling, but I'll confirm the timings and the day for that. And then you'll also get access to the next week's mission. So every week you'll see the missions being added here with the projects, with the essential knowledge, and where do you get started from there on. So you'll have an understanding of that. In case if you are interested in the membership, you can get started with any of, we have 2 levels of membership right now, silver and gold. Silver gives you access to the containers workshop. Earlier it had only 2 courses, DevOps Mastery Blueprint, in case if you want to get started with DevOps as a career. This is useful. This is like a program you can finish in 3 days. You have lifetime access for all of these, but you can finish this in 3 days. This is a boot camp that I'm changing now. This is, you can finish it in about 30 or let's say 45 days or so. And it takes you through a project, but I'm going to make this more detailed, elaborate, and so on. So right now, the challenge which becomes part of our silver membership is going to be this container Kubernetes challenge, because Kubernetes is the #1 technology that all of you should know about and everyone should absolutely get started with. I have been conducting surveys, I've been conducting a lot of research around it, and all the indicators tell me that Kubernetes is the most impactful technology for your career if you want to be a DevOps professional. So that's why I've put the container course here from the gold to silver now. And there are some bonuses out there, and you get access to the 50-day Kubernetes challenge. And I'm going to run this as a continuous program. The website price is $197, but you will receive an email with a price of $97 if you want to, since you have attended this live session, etc. And then on top of that, I'm giving you offer which is valid for next 15 minutes. This is to reward the action takers. If you really want to take action, because I really believe in people who would take an action, and they're the ones who we want in the community to participate and all that, right? Because that is the way to get things moving. And rather than because you read a lot, you can find a lot of resources on the internet as well, but unless you actually start implementing things, you will not really move forward, right? And the whole challenge is designed to motivate you to implement it, because I have courses, I've sold courses to thousands and thousands of more than 100,000 people, and I know for the fact that the course completion rates are typically lower in case of online courses, and unless you have something to push you, it wouldn't happen. So I really want people to benefit out of the programs that I have and the courses that I have. And that's why I'm also designing. That's another reason why I'm designing these challenges as well, which you are part of now. This is a silver membership. We also have the gold membership, which is more a detailed mastery programs, including, let's say, the AWS and Docker Kubernetes as well, but that is coming to silver anyways. And then Ansible and Terraform and CI/CD. And I have published a bunch of courses for Linux Foundation. And I'm allowed to publish it through my portal as well. And that includes courses on CI/CD. Fantastic course, has run very well, received like really good reviews. There's a DevSecOps course, there's a GitOps course. So once you understand Docker and Kubernetes, next thing that you do is start setting up a CI/CD for it. Then you incorporate security practices to it. Then you do GitOps or automated deployment with it, right? And that's what you can take. Plus, there are lot of bonus courses. So this includes everything that I've created so far in terms of my courses, almost everything that is part of my gold membership. Right now, I'm giving you, you can always upgrade from silver to gold as well. And I would be running another promotion for the gold later this week for Black Friday. But for the action takers, I believe you are one. I am offering a couple of resources here, which you can sign up for the students in India and students everywhere else. I have these two resources for you. So let me just show you those. I'm giving you the links basically. These are the offers for the action takers. And if you take the action in the next 15 minutes, because these links will be available only for the next 15 minutes, I'll be taking those offline after that, 15 minutes after the session ends, basically. Right? So you can take 15 minutes after the session ends. So if you want to sign up from India, this is the link. For rest of the world, we have this link. Yeah. So it's devopsclub.co. That's the domain I've bought for sharing the links quickly. Easy to remember. Devopsclub.co. And this is the action bonus for India. This is the action bonus in US dollars. So Indian rupees, US dollars. If you go to this, you will see what is the current price, the offer price. This is only for the 15 minutes, right? So this is the best offer that you would get ever for this course. The silver membership at 5,999 instead of 7,999, which is my offer in the email. And the rest of the world, you will get it for $77. Again, that's the best possible offer that you're going to get ever. If you do that, if you take a decision in the next 15 minutes after the session ends, basically, when we go offline. So make use of that if you're really serious to get started with it. And this will give you a structured path more than anything else. You still would have access to the challenge. You're going to get the access to the challenge course anyways, not to my actual container course, but the challenges will be shared with you. And you are going to get access to the live session anyways. So even if you don't, you can get access to the live sessions and the challenge, anyways, right? So you'll benefit either ways. I'm hoping so, and I'm hoping that you participate in the challenge and really keep track of, really complete all the tasks and the projects, and that would definitely gonna benefit you to master Kubernetes, or start getting, building that foundation towards the Kubernetes mastery, I would say. That's about the membership. Any other questions? I see a bunch of questions, but I'll actually mostly take those later. And if you don't find answers to your questions right now, you would basically find it, through my YouTube channel. So if you haven't subscribed again, you can go to youtube.com/c/c/@ and School of Devops. So do subscribe to that. And I will be sharing a video shortly in case if there are any further questions that require me to answer, either through shorts or through videos. I'll be reaching out to you with the answers to your questions. With that, we get started. I wouldn't say end the session, yes, but we get started with this challenge. And I want you to complete this entire challenge and see the benefit out of it, right? And if you just keep track of on track, basically we're gonna start today, and we're gonna go for 7 weeks approximately. There'll be no session or activity during the last week of December. We will all be shutting down, even our work here. So we'll take a quick break there for a week, but otherwise you will finish this by, let's say, the week of 16th of Jan. So I'm just approximately putting the date as Jan 20th, unless there is any other change in between. And that's the plan from now on. And with that, we will mostly close our sessions. Any questions from anyone in the Zoom channel or from, I'm watching YouTube right now, the YouTube stream. So any questions from there? Let me know. All right. So with that, then we will close our sessions. I'm just going to wait for a few seconds. And otherwise, we'll be closing the sessions there. And be assured that if you have any questions which are relevant to the topic, I would definitely, be reaching out to you. And that's that. So in case if you want to join the subscription, join the basically these courses and the programs, and you get not only courses, you have access to, through the membership, you have access to 4 C's: challenges, courses, coaching, and community. And if you calculate the benefit, it's you'll probably achieve or can get 100 times returns out of this as well, very easily. And this is just the silver membership is just starting. So I see a question or a comment there. This is just a beginning. We have additional levels of membership as well, which will benefit you even further. If you're serious about making DevOps careers, you could definitely consider those. Or you can, so you either you spend time learning, or you spend money to get on the fast track. This is more like a toll road that will get you from point A to point B in the shortest path. That's pretty much about the membership model. And challenge is open to everyone. So you can also let your friends know about it and have them participate in the challenge as well. So with that, we'll conclude today's session. So thank you very much. And I'm going to see you next week. I'll be sharing the details of the live session next week or further. So, just watch out your email, and you will receive access to the challenge and the portal, and you can get started with it tomorrow onwards. So that's it from my side. Thank you, and bye-bye. We're closing.